everybody. This is Kevin Sachin James from first trimester E section. My roll number is 25MIBE19, and today we're going to be talking about the computer system. So the computer system contains hardware and software. Hardware is our external devices, and software is internal devices. So under hardware, the hardware consists of processing units, storage devices, input units, and output devices. So under processing unit, we have our motherboard, our GPU, and a chipset or SoC. Our motherboard is nothing but our brain of the computer. So the motherboard consists of a CPU and RAM. We also have GPU. The GPU or the graphics processing unit is the unit which runs all the graphical processing of the computer. For example, we have our video games or any video editing software that uses the GPU. The chipset is nothing but the processor of the computer. For example, we have Ryzen processors or Intel processors, so on and so forth. Um, and also, uh, under storage devices, we have our primary storage, that is our volatile storage. Volatile as in temporary storage. So we have RAM storage, registers, and cache memory that comes under our primary storage. So volatile as in it's a temporary storage where um, we need fast memory. For example, when we are typing a Word document and the computer switches off or there is a power cut and the PC is cut off from the power, that is so that when that happens, the Word document is not saved directly on the secondary memory, but the primary memory. Yeah, and we have secondary storage devices, that is our non-volatile devices, which contains our SSDs, our hard disks, magnetic tapes, NVMe drives, optical disks, that is CDs, DVDs, or Blu-rays, our USB flash drives or pen drives, and our SD cards. Then we have input devices and output devices, which I will be going into further detail in some time. Now coming to software, our software is nothing but the system the computer runs on. So we have our system software. For example, we have our firmware, our utility programs or device drivers, and especially our operating system. So these are the software that basically runs the computer. Then we have middleware, that is our web servers, API gateways, and database middlewares. And also we have application softwares, applications that we install or sometimes pre-installed. So those are productivity software, for example, Word, Excel, Adobe. Our enterprise software, which comes under which is pre-installed on our laptops or mobiles. Then our mobile apps, which we download separately. Our media players, games, web browsers. So now I am going to be talking about input and output devices. So a computer has input and output devices. So input devices are nothing but where the devices that send data to the computer for processing, and output devices are the devices that use the data that has been sent from the input device, processes it, and gives some sort of output. So talking about input devices, we have a couple of examples. Like text input, we have keyboard. For pointing devices, we have mouse. For image input, we have scanners, cameras, webcams. For audio input, we have microphones. And specialized input, for example, where we have touchscreen, where a touchscreen on a mobile or certain laptops have been specifically designed to be used as an input device or a game controller. For output devices, we have visual output, that is a monitor or a projector, audio outputs, that is speakers or headphones, and printed output, that is printers or plotters. The CPU and the mind map that I've used to talk about the CPU. So the CPU is the is in a way you can say that it is the brain of the computer. So the CPU executes instructions and processes data. It has multiple subunits that work together to perform tasks. The first one is the instruction decoder. So the purpose for the instruction decoder is it reads and interprets instructions from program that is stored in its memory. It converts instructions into signals that the CPU's control circuits understand. Then we have control registers. So the control registers store and manage and control information required for CPU operation. It keeps tracks of instructions, memory addresses, and CPU status. So now next we have the general purpose registers. These temporarily store data and instructions during the execution. It is used for quick access to data instead of fetching it repeatedly from the main memory. Then we have special purpose registers. It is used to store or control status information, example program counters or stack pointers. It helps to manage the sequence of operations. A clock, it is used to send timing signals to synchronize the CPU operation. It controls how fast the CPU processes instructions. The arithmetic operations is to perform basic mathematical operations like addition, subtraction, multiplication, and division. It is part of the arithmetic and logical unit, or the ALU for short. Then logical operations. It is used to perform logical comparisons, that is AND, NOT, OR, NAND, etc. It is also a part of the arithmetical logical unit. Then shift operations. Its purpose is to shift bits left or right within a binary number. It is useful for multiplication and division by powers of 2. It optimizes data manipulation. In cache data, it is high-speed memory inside the CPU that stores frequently used data. It reduces the time taken to access data from the main memory. Interface unit, it manages the communications between the CPU and other parts of the computer. It coordinates input and output operations. Bus interface unit, it connects the CPU to the system bus that stores data, addresses, etc. It is used to transfer data between CPU memory and peripherals. Let's talk about the role of IT in the business sector, or role of information technology in the business center. This mind map shows the key roles information technology plays in the business with central theme, IT in business, branching out into major categories, each representing a benefit or function of IT. So, IT efficiency and IT automations. Respective tasks are integrates systems like ERP and helps reduce operational costs. Decision making. Business use, data analytics, reporting tools, and business intelligence software to make informed choices. In communications, emails, instant video messaging, conferencing, and shared platforms improve collaboration between teams with customers. Customer engagement, tools like CRM systems, e-commerce sites, and AI chatbots allow companies to serve customers better and personalize their experience. Innovation, cloud computing, AI and emerging tech support new product development and process improvements. Security. Cybersecurity system compliance tools and backup solutions protect data to meet legal requirements. Remote work like cloud apps, VPN access, and collaboration platforms allow employees to work effectively from anywhere. Competitive advantage, fast market entry, customer insights into customer and optimized supply chain help business stay ahead. Now we will be talking about the flowchart of the booting sequence of a computer. So let's take a look at the flowchart. So in this flowchart, we talk about the computer booting sequence. So The first step in the computer booting sequence is the user presses the power button, which this sends power to the motherboard, CPU, and other components, and the computer begins its startup process. Then the CPU executes a hard-coded jump instruction from a CPU register. A jump instruction is a built-in command telling the CPU to go into a specific memory location. This is the first thing that the CPU does after getting its power. Then the CPU jumps to a predefined memory location in the ROM where the BIOS is located. Then the CPU starts executing BIOS directly from the ROM. The BIOS firmware is that firmware that controls the basic hardware setup and testing of a computer. And the BIOS performs hardware tests uh, or a power on self-test. So the power on self-test checks if the critical hardware like RAM, CPU, and keyboard and displays are working correctly. If the POST fails or the power on self-test fails, the booting halts. If not, if it succeeds, the BIOS continues to the next step. So the BIOS loads the partition table into RAM and starts the first partition. The BIOS finds the bootloader in the storage device like a hard drive or an SSD, and the bootloader then loads the operating system into the memory. In short, the power up and load has been performed by the BIOS, and the hardware check is done by the POST, and the load OS bootloader start the operating system.